Dear students, we have discussed about the modular approach and module should be built. Today, we will further explore that what is coupling and more specifically the intermodule coupling. So we have discussed the advantages of modules, that any modification will be applied to few of the modules or only one of the module. So other modules will remain intact, and assumption is that changes in one module will not affect other modules. So this is our assumption, and the goal is maximize the independence, minimize linkage between modules, known as intermodule coupling. So this means we want to minimize the linking between the modules. So each module should be self-contained and it should not be dependent on other modules. So this is the required goal to build an intermodule coupling. So this is one of the metric. So suppose if there is a software which has high intermodule coupling, this means that this software is a complex software and the cost of such a software will be very high. If all of the modules have very less intermodule coupling, they are not dependent on each another, this means that this is less expensive to maintain such a software in long run. So there are different types of couplings. One coupling is known as control coupling. So this occurs when a module passes control of execution to another, as in a function call. So such a coupling is known as control coupling. For example, our main module control game calls the serve module. So when this control will be passed to serve module, this is called control coupling. Similarly, this call the return module, the compute path module, and the update score module. So whenever a module passes control of execution to another, it is known as control coupling. And then there is a data coupling, because there could be number of data elements which are being accessed by multiple modules. So refers to the sharing of data between modules. If two modules interact with the same item or data, then modification made to one module may affect the other. Because, for example, there are two modules A and B, and A has changed the value of a data element X, which is also accessed by B module. So this means there is not direct connection between module A and module B. They are not dependent on each other, but they are dependent based on the data which is available and which is accessed by both of the modules. Then there is how to handle such a data coupling. There are two methods. One method is explicit passing. So this means this function will make all of the changes to variable X, and then this X will be passed to this function. So such a thing is known as explicit passing, passing by parameter. For example, control game will tell the function serve which player's characteristics are to be simulated in the game, and when it calls serve function, that the serve function will report the ball trajectory to control game function when serve has completed its task. So such a passing of data between different modules is known as explicit passing. Then there is another concept of global data. This means that data items are automatically available to all of the modules. So for example, if there is a module A and there is a module B, but the data element X which is being processed by A and B is not the property of any particular module. However, it is residing on somewhere which is at certain place which is accessible to both of the modules. So this is called global data. So data items that are automatically available to all modules throughout the system. So I will summarize today's module. We have discussed about coupling, intermodule coupling, and we have discussed that what is control coupling and data coupling.